I'm Kathleen Stewart and I'm a representative for Hanger Incorporated, where we find materials to fit your company's needs. What is Hanger all about, you ask? Well, you guys already know, but it's to provide safe bone and dental implants to place inside their customers to create durable and long-lasting bone replacement. We're trying to create hard, non-toxic, and non-dissolving implants that will be non-poisonous to your customers, hard enough to be able to be in any situation with the human body, and finally non-dissolving because there's lots of water in the body and we don't want it to be soluble. To fit your company's needs, we've looked at 4 different types of materials. First, metals, specifically steel and platinum. This category was one of the best. It was hard, somewhat strong, and not stretchy, and a heat conductor. The heat conductor isn't the best because we don't want the bone implants to overheat and melt in the body, but other than that, it's a really great qualities. Secondly, there's woods and fibers, and we specifically looked at white pine and birch. These didn't fit the needs of your company. First, because it sounds really weird to have woods inside the human body. Second, because it's soft, weak, somewhat stable, and easily heated. So we don't want it to be rotting inside the body, and it's too soft and too weak to be a durable source of bone implantation. Third, we looked at ceramics, specifically alumina, tungsten alloy, and silicon carbide. These also fit your needs because they are very hard, very strong, and not a heat conductor. These are the best categories to be using with the bone implants. Finally, we looked at polymers, specifically acrylic resin, polyphenylene, and polyurethane. These are soft, somewhat strong, stretchy, and can be hot, get easily hot. This is a lot like putting silly putty in your body, and that's not what we want for bone implants. Because we know about the hard, insoluble, non-toxic properties that you guys need for your company, we need metals and ceramics to go inside the body. These are the 2 kinds of properties and categories that we are going to be using with the implants. The material we recommend is titanium with hydroxyapatite. This contains all the properties of hard, non-toxic, and insoluble. It's hard on the inside with titanium being on the inside, like shown in this dental implant. And then on the outside is hydroxyapatite, which is a bioceramic, which means that it will not react with the body, and it won't react with the body, and it will just create a nice replacement of the dental or bone implant. Yes. Moving on, this is what the material will look like from an atom form. This in the middle, these bunches of circles are like the titanium molecules because they're so bunched together, showing that they're a metal, because metals have the molecules sticking all together. And then on the outside is that hydroxyapatite. We couldn't show that specifically because there was no, we didn't know how to show it in an atom form other than exactly like titanium is shown. So just the chemical equation is shown, which is Ca10PO4 6OH2. Inside of these atoms are the intermolecular forces within the model, which is what's happening in between in between the molecules. The one interaction that is happening in between the molecules is the dipole-dipole interaction. It's the strongest force between the molecules, which shows that it's in the metals because metals are the strongest and they are solid, so they are sticking together very closely. And one that you might think would be between the molecules, but actually isn't, is the hydrogen bonding. This is stronger than the dipole-dipole interaction, but it has to be between hydrogen, fluorine, oxygen, or nitrogen. Finally, the intermolecular forces within the molecule, which is happening inside one of these circles, not in between both, but only inside one, is the metallic bonding, because obviously it's a metal, metallic bonding would be happening. What's happening inside of the metallic bonding is the protons stay stuck and the electrons are freely moving around everywhere. Because of the electrons moving around, this shows that it's like an easy heat conductor and electricity conductor, which is why metals are electric and heat conductors. Because of the hydroxyapatite on the outside, it won't be a heat conductor or an electric conductor, so it's still good for our implants. Because of these two very simple products that we are putting together, it's going to be affordable enough for your customers, but still enough for the company to make a profit. These are two websites that are used to find information about the bioceramics, what specifically you need for your company, and for the titanium to see what would be best fit on the inside and best for the body. Thank you.